Okay, question 11 of exercise 3.2a. Find the sum from r equals 5 to n of r plus 1 divided by r cubed minus 6r squared plus 11r minus 6. And it says where r is greater than or equal to 5, but that's already implied here from this sum. Maybe it meant to say where n is greater than or equal to 5. I guess that would have made more sense. In any case, let's get started. So it's not immediately clear what to do, but we're in the section about using method of differences to solve these things. So it looks like partial fractions would probably be a good idea. And we have that cubic polynomial on the bottom there. So let's see if we can factorize that. Now, if we try some values of r, for example, r equals 2. I mean, you stare at it for a little while, and r equals 2 is obviously a good choice. Then you get 2 cubed is 8 minus 6 times r squared. So 8 minus 24 is 16. Minus 16. And then plus 22 is 6, minus 6 is 0. So that means that r minus 2 is a factor of this thing. And we also know that, well, what's another good number to use? I mean, 3 is another one, because if you put 3 in there, you get 3 cubed is 27 minus 6 times 9, so minus 54 plus 33 minus 6, which you can check is 0. Alright, so r minus 3 is another factor of this thing. And what else? And at this point, I'm too lazy to find the last one, so I'm just going to use polynomial division. So r squared minus 5r plus 6. Okay, and then we want to put that into the polynomial on the bottom there. So r squared minus 5r plus 6 into r cubed minus 6r squared plus 11r minus 6. So we do our multiplication, r cubed minus 5r squared, and then plus 6r. Okay, we do our subtraction, we get negative r squared. Really? Okay. Wait, so 1 works? 1. Oh yeah, 1 works. God, I feel dumb. Okay, that's silly. Okay, so minus 1, and then we don't need to do anything else there. So please ignore my stupidity. This whole thing is actually equal to the sum from r equals 5 to n of r plus 1 divided by r minus 1 times r minus 2 times r minus 3. So yes, we would like to write this in terms of partial fractions, and according to the partial fraction decomposition formula, we can write that as a over r minus 1 plus b over r minus 2 plus c over r minus 3. Okay, now let's see what these things turn out to be. So we should get r plus 1 is equal to a times r minus 2 times r minus 3 plus b times r minus 1 times r minus 3 plus c times r minus 1 times r minus 2. Okay, and then letting r equal 1, we get that 2 is equal to negative 1 times negative 2, which is 2, so 2 is equal to 2a. So that would imply that a is equal to 1. Okay, and then taking r equals 2, we get that 2 minus 1 is 1. Well, over here first, we get that 3 is equal to, so 2 minus 1 is 1 times 2 minus 3 is negative 1, so that will be negative b. Okay, so that will be b is equal to -3. And lastly, r equals 3. We get that 4 is equal to 2 times 1, so 2c, which would tell us that c is equal to 2. And so we are looking for the sum from r equals 5 to n of 1 divided by r minus 1, minus 3 divided by r minus 2, plus 2 divided by r minus 3. And I think it's pretty clear what to do here. We can split it up and then use our distributive rule. So the sum from r equals 5 to n. So we want 1 divided by r minus 1, and then I guess minus 1 divided by r minus 2, and then minus 2 divided by r minus 2 plus 2 divided by r minus 3. It's going to make things easier. Okay, and then that is equal to the sum from r equals 5 to n of 2, well, I'll say 2 times the sum from r equals 5 to n, and I'll take care of this part first, of 1 divided by r minus 3 minus 1 divided by r minus 2. Remember, we should have the r minus 3 before the r minus 2, because r minus 2 is 1 bigger than r minus 3. Okay, and then let's do something similar here. So minus the sum from r equals 5 to n of 1 divided by r minus 2 minus 1 divided by r minus 1. Again, if we consider this as our f of n function, this r minus 1 is going to be 1 bigger when we put in r plus 1 to it. So we want this one to be second. Alright, and then we are good. This one here, our function f of r is clearly 1 divided by r minus 3. And since we're starting at 5, it's going to be f of 5 minus f of n plus 1, which is going to be equal to 1 divided by 2 minus, and then over here 1 divided by, wait, what am I doing? N plus 1 into here. So it'll be n plus 1 minus 3, so 1 divided by n minus 2. And then over here, our function f of r is equal to 1 divided by r minus 2 this time. Okay, so then this one is going to be f of 5 minus f of n plus 1, which is equal to 1 divided by 5 minus 2. So that'll be 1 divided by 3 minus, then we put n plus 1 into here, 1 divided by n plus 1 minus 2, so 1 divided by n minus 1. Okay, and then let's continue with the green. So 2 times this thing is equal to 1 minus 2 divided by n minus 2. Okay, and then it's just going to be minus these ones. So minus 1/3, and then plus 1 divided by n minus 1. So that is 2/3 minus 2 divided by n minus 2 plus 1 divided by n minus 1. And we can simplify it into a single fraction, because I think that's what we're supposed to do. So 3 times n minus 2 times n minus 1 on the bottom there. And then 2 times n minus 2 times n minus 1. And then minus 2 times 3 times n minus 1. So 6 times n minus 1. And then the last term is going to be just plus 3 times n minus 2. Alright, continuing along, to simplify, so this is 2 times n squared minus 3n plus 2. Okay, and then minus 6n plus 6, and then plus 3n minus 6. Divided by 3 times n minus 2 times n minus 1. 6's cancel. Okay, and so this is equal to 2n squared, and then minus 6n, and then minus 3n. So minus 9n, and then plus 4. Divided by 3 times n minus 2 times n minus 1. And if you like, you can factorize the thing on the top however you want. I'm going to do it this way. 2n squared minus 9n plus 4 equals 0. And solving that equation, you get n is equal to a half, or n is equal to 4. And so that means it's the thing on the top is equal to, well, 2 times n minus a half times n minus 4, which means 2n minus 1 times n minus 4, and then the whole thing divided by 3 times n minus 2 times n minus 1. And so we're done.